Okay, guys, I think we can start. Okay. So, last class we have been discussing about the deep learning framework and how we can interface deep learning frameworks to ROS2. It's basically like we are subscribing to the image and then we are converting into OpenCV or NumPy and then feeding into the model. Okay, so that is how we have been doing that stuff. And today we have something new. I will not say it is new to us because we already have seen the same topic in ROS 1. So these two topics we will be, seeing again in ROS 2. Mostly the things are the same, but it is very useful. Okay. So the first topic that we are, okay, 1 second. Let me start sharing the screen. 1 second, guys. Okay. Hope you can see the screen. Okay. Yes. So the first topic that we are going to discuss is Docker. And the second topic is continuous integration. Like how to set the continuous integration for ROS 2 projects. Okay, so these are the two things that we are going to see. And I will be starting with the Docker introduction, and then we will be seeing how to work with Docker and ROS2 and all this stuff. Okay, so let's start with Docker. I hope you have some idea about Docker, but um, I can explain what Docker is and why we need to learn Docker in this course. Okay, so that is the important part of it. 1 second. I think Docker in, oh yeah, digital list. 1 second. Okay, yeah, this is installation, and maybe I can compare with VM, so that will be also good. Okay. Yes, so I think this image will be better for an explanation. Okay, so the problem with ROS 1 or 2, if you take any ROS version, there are a lot of dependencies actually, right? There are a lot of dependencies, and in order to build a package, or in order to compile, or yeah, basically build a package, you need to satisfy these dependencies. Okay, so imagine you created a software. Okay, you created a package or some set of software, and you have to deploy in a different machine. Okay, so what you have to do, like you have to set up the dependency along with your software, then only the software will work, right? So one way of installing the dependency is like you can write a shell script or something to install dependency, or you can simply node this dependency and install using apt install or something. Okay, that you can do. Or what you can do is, if it is like a simulation application or something like that, you can use a virtual machine. Okay, like VMware or VirtualBox. So you can set up your application in a VMware or virtual machine, and then you can copy the files to another machine. Okay, so if you are going to install in the main system, then you have to node this dependency and you have to install it. If it is a VMware or something, you can simply copy the hard disk file. Okay, and there is another way to run the application with the dependencies in a better way. The problem with the VMware or virtual machine is that you have to install the full operating system, and you have to set it up and you have to copy. So the operating system that we are working, I mean the guest operating system, you can see here the VMware. So this is the VMware. So the operating system that is working on the top of the host operating system. Okay, in this case, here Ubuntu is the guest operating system and we are running on Windows. Okay, so host operating system is on the bottom, and in case of VM virtual machine, there is a software called hypervisor. Okay, that is actually the virtual machine software. Has that software can able to run multiple guest operating system, and the hypervisor will be sharing the system resources for each guest OS. Okay, it is actually sharing the resources like CPU, then RAM, graphics, all this stuff. Okay, so the most what will I say, optimized way of doing or deploying an application is using a technology called Docker. Okay, Docker is nothing but like very similar to the VM. Okay, but it is more close to the kernel of the host operating system. Okay, so it is not like sharing or wasting some resources like the VM is doing. It is having less overload compared to the VM. So it is like, it can, if you install an operating system using Docker, it will be using minimal resources. I mean, it will work along with the host operating system with less. Less means it will not it will not take more resources like the VM. Okay, it will be working like a part of the host operating system. So that is why the Docker is getting very popular. You can install an operating system, you can install the dependency and run your application in multiple machine. Okay, so in case of ROS, there are multiple versions of ROS, and there are many dependencies as well. So it will be better to use VMware or Docker. Docker is what I prefer, but the problem with the Docker is it will take some time to learn the concept. Okay, so the Docker is an actually it's a application you can install on Ubuntu and Windows, and then using the command line interface mainly, you can install the different operating system, and also like you can directly directly pull the ROS2 image. ROS2 image means it will have Ubuntu with the ROS2 installed. So it is very easy to deploy an application because you can simply download it, and you can copy your application and run. Okay, and there is a thing called Docker Hub. That is the interesting part of Docker, in which there are some existing images available. Images means the files that we can able to run. Okay, it is actually having some operating system like Ubuntu or something, and there will be some dependencies installed. So if you search about ROS or OSRF, you will get the complete package. I mean, images. Maybe I can I'm sharing the link of Docker Hub. So Docker Hub is like a place like GitHub in which these images are getting pushed. Okay, these images. So if you want to work with ROS in Docker, you can simply install Docker and simply execute this Docker pull ROS. Okay, so it will be pulling the latest image from the Docker Hub. So image is basically having an operating system and all these. It's based on which image that you are pulling. If you are pulling like ROS Neutic, ROS Core, or like if you can pull any of this tag, So based on this tag, it will be that image will have that ROS version. Okay, so you don't need to download Ubuntu and install ROS on it. It is already there. Okay, not only ROS, like if you want to simply get Ubuntu alone, okay, just Ubuntu, just search for Ubuntu and you will get the plain image, like it doesn't have any ROS or something. So if you want to test anything, you can get the image of Ubuntu. And these images, there are some speciality in this image. By default, this image doesn't have any desktop environment or anything. It will have the core elements, okay, only the core elements. So after pulling this image and executing it, you have to set up other dependencies and then copy your application and run it. Okay, so basically Docker is like we can create an image. Okay, we can copy it from one PC to another, or you can put it in the Docker Hub and you can download it and run it. Okay, it's like VMware. You can compare Docker and VMware, but VMware, obviously it is I mean, the size of the hard disk will be the size will be very high, but Docker is only keeping the core element in the image. Okay, it is actually keeping the core element, so the size will be less, and you can install the particular dependency and then it can run. So it doesn't have any other packages. Not only packages, like for example, if I am working with VMware, so I'm having full desktop environment, right? I'm working on ROS only, but so I don't need the writer, right? I don't need the rhythm box. So if you are working on VMware or virtual machine, you have to manually delete all this stuff. Okay, but in Docker, what we are getting is we are mainly getting the kernel and the command line, just the basic stuff. You can maybe install desktop, you can install the application, it's all our choice. But like in order to run your specific application, for example a simulation in Gazebo, you don't need the desktop environment. You just need to install the ROS and then you can simply execute all this stuff. I think, Heidi, your mic is not mute. Maybe you can simply mute the mic. Yeah, thank you. Okay. So that is how Docker works. Okay, I will give more explanation. So in order to install Docker on Ubuntu, so this is the instruction that I am following. Okay. So Docker is pretty easy to install. You can install through the apt install command. So just do the ROS update and then install the certificate and then download the key. Then just use docker-c to install this command. Okay, so if you follow this instruction, you can able to install Docker. And when you install Docker, it will be running a daemon. Daemon means, in Linux terminology, daemon means a background process. Okay, background process. So you can able to see the background daemon is working or not. For example, I already installed the Docker in my VMware. So if I'm simply copying this and then if I'm taking a terminal and pasting it, giving the 1 second, you can see the Docker daemon is active. Okay, so if it is active, then you can able to start working on it. Okay, so that is the process of installing Docker. And after that, you have to add the Docker, add the user into the Docker group. Okay, so these are some other commands that we need to do. This is mainly for permission. Okay, so if you install Docker, the Docker will be creating a user group called Docker. Okay, so your user, currently my user is a robot, that user should be adding to the Docker group. So that is what these commands doing. Okay, so after that you will get into the current user will get into the Docker group, and then you can access it. Okay, so after installing the Docker, you can simply type Docker, and you can able to see the sub commands. Okay, sub commands. So the first command is like, if you do docker info, you can see the list of version, I mean what version that we are using, and also all the plugins in Docker, and also the total memory, all this stuff. Okay, and this is what the first command that you can check to make sure the Docker is working. So here what we are doing is we are pulling a hello world image. Okay, hello world image is basically, I think it is Ubuntu itself. I guess it's simply Ubuntu, and it will just print hello world. Okay, so docker run, if you run these command, okay, docker space run. Okay, so in order to understand what is run, you can simply enter docker and just check the sub command called run here. So run command create and run a new container from an image. Okay, so I can explain it. Okay, so what happening is that so if you run this, what Docker check is that it will be checking this image is already available in our machine, or is it there in some part of the I mean Docker is actually saving the image in some location, so it will be checking whether the package is there or the image is there. Okay, if it is not there, then it will be downloading from Docker Hub. Okay, so I'm just running it, and you can find a message unable to find image hello world latest locally. Okay, and then what happened? Then it is downloading the newer image. Okay, and there is a message printing, and you can see hello from Docker. Okay, and there is another example, like if you want to run Ubuntu, and if you want to access the bash, you can write like this. I will be discussing that. So this is how the Docker actually work. If you want to start an operating system, you can simply mention docker run then the image name. So if you are running the image of an Ubuntu, the Ubuntu will be booting up, and you can access the terminal or GUI, whatever it is. Okay, and so there is another keyword that I have to mention. So there is a thing called container. Okay, container is nothing like image is actually the file that we are going to run, and when you start the image, okay, the image is having the Docker image is having the operating system, and when you start the operating system from the image, it will be called a container. Okay, it's a kind of instance. Okay, so the docker run command basically starting the image and creating a container. Okay, starting a container. So container is like a runtime entity. So if I am starting this, it's basically creating a container and running it. Okay, so in order to check the list of images in the system, you can just check docker images. Okay, you can use docker images, so you will be getting all the command from internet. If you just check the docker command line, cheat sheet or command line, you will get all the um, uh, important commands. Okay, 1 second. Yeah, I think in their website they are mentioning, but it's not in a proper way, but I can explain the important things. So you can simply check Docker space images. It will be showing what are the existing images that is available. Okay, so if I want to run Ubuntu, okay, Ubuntu basic, so I'm actually going to run a command, and I will explain the thing after that. 1 second. Okay, so can you understand what is happening? Using run command, we are starting the Ubuntu image with version 22.04. So we have to use like this, and IT means interactive. Okay, so we are starting Ubuntu and we are starting the bash of it. Bash means the terminal. So basically we are starting Ubuntu, and then we got the terminal of it. So this is the terminal of the container, Ubuntu container that we have created. Okay, it is not the current terminal. I mean, this is our terminal, right? This is the this is the terminal from the container. And if you do docker ps, you can see docker ps means it will be listing the current running containers. Okay, so you can see there is a container ID, then the container is forming from the image 22.04, and the command was bash. Okay, so maybe I can able to show you. So there is a container, right? We are inside the container. So I'm just creating a file called lentin.txt in the container. Okay, maybe I can do like this, because in the container this is like a very lightweight version. There is no commands like sudo, nano, nothing is there. Okay, you can install the packages as well. Okay, that you can do. So maybe I can do the apt update inside this, and so you can do all this installation, and even after that you can export this image as well. So if you want to set up your application inside a container and you want to export it, you can do that as an image. You can export and you can copy to other computer as well. Okay, so I'm just installing apt install nano, and nano is getting installed. And oh, 1 second guys, it got log out. Okay, 1 second. Yeah, so using nano, what I'm doing is I'm just creating lentin.txt, and I'm just showing hello from Lentin. Okay, so you can see the file here, lentin.txt. Okay, so if we want to, so currently we only have one terminal access, right? One terminal access. If we want to have multiple terminal access of the same container, what I can do is I can first check the container ID. Okay, so this is a container ID. So I can use another command called exec, not run, exec -it container ID and bash. Okay, so this is a command, docker exec. Exec means it is actually running on this container ID that we have provided. Okay, so it is not creating another container, it is actually getting into the existing container. And if you do ls, you can see the lentin.txt, and if you visualize it, it's hello from Lentin. Okay, so we are accessing two terminals of the same container, and I'm just accessing from this terminal, and I'm just adding Lentin Joseph, and from this terminal I am just checking this, and you can see this. Okay, so we have we have seen how to run a image and make it as a container, and accessing the bash and accessing multiple terminal. Okay. Okay. So yeah, so in order to exit from it, you can either press Control D. Okay, so it will be exiting from the Docker container, and it will be exiting, and also Control D. Okay, and you can check Docker PS. So currently there is no container running. Okay, so this is a basic, the main command that we need to understand. Okay, so we have a question like what will you what is the use now, like whether we can run ROS or something. Yes, we can run ROS. It's very easy. Like you can pull the rows image, okay, rows image, and then you can able to work with rows. That's it. It's very simple. Okay, so maybe I can show you the stuff. So Open Robotics actually giving a tool to us. Okay, it's called Rocker. Okay, Rocker. So the Rocker is actually a script which is working on Docker. Okay, and why we need to use Rocker is that Rocker make our life easier, I will say. Okay, Rocker will help us to run rows to image or any image with graphic support. Okay, so for example, if you want to access Gazebo or RVs, RQT, you can use Rocker, or you can manually use Docker to run it. But Rocker is what I am preferring actually. Okay, so what I am going to show you is that first I will be showing to work with rows to Humble from Docker itself, and then after working with Humble and all, we will be working with Rocker to show some GUI stuff. Okay, okay, so what I'm doing is I'm actually running Docker run. Okay, and so this example is already there in the rows to rows to not example documentation. So I'm sharing that as well. So what we are going to do is we are downloading an image of Humble. Okay, so this is the command. You can either do Docker run or something. So if this image is not available, it will be going to the Docker Hub and downloading it. Okay, so let's see what will happen. Okay, so if you do this, it will take some time, guys, but let's see. It is checking and checking the Docker Hub and downloading the image. Okay, so you don't need to install rows and all. It's already there in the image. I can show you. 1 second. So it is downloading layer by layer, and after completing, this image will be saved into our machine and we can able to run it. Okay, so let's wait for some time. Let's see. Okay, so it will take like 1 or 2 minutes. And yeah, so after installing or downloading it, let's see the next thing. Okay, let me check some other stuff. Yeah. Okay. Yeah. Okay. So it seems like it will be downloading now. I mean, it's almost, yeah. So if you do the Docker images, you can see there are two images now. But after completing it, you can able to see the rows image as well. Okay. Obviously, it will take time because this is the rows image, right? So on the top of the Ubuntu image, we have to install the rows packages and all the dependencies. Okay, so let's wait for some time. And so based on the so this I didn't share the link, right? Yeah, I shared. So based on the based on the image that we are using, we can work on different rows distribution. Okay, just use this command and it will be downloading, so you don't need to install rows separately. Okay, so that is the thing. And as I mentioned, using Docker, we can install whatever we want, whether it's GUI or any tools, and you can access it and run your application. Okay, there is no limitation. By default, there is only the basic packages, the core packages will be available in almost all the images that we are downloading. And based on the application dependency that we have created, because if you are working on some perception project, we need to have OpenCV installed, so we have to install it. Okay, so all these things we need to install separately. So here I think the pull is completed. Now it's, I think, extracting. Let's see, seems like it is taking some time. So maybe I can go with the explanation. So after pulling it, you can able to run it using this command. Okay, docker run it. So I think it will work. It will be showing the terminal, no need to add bash. And after that, you can work on the rows2 commands. You can do the rows2 package list, all these things you can run, and even you can run the examples. Okay, the demo example that is already in the rows2 image. Okay, and yeah, finally they are introducing a concept called Docker Compose. I will be getting into that. Docker Compose is like if you want to run multiple Docker images, and if you want to deal with multiple containers, this is like a launch file, rows launch file. So you can mention what are the containers that we have to run, and then we can launch it using Docker Compose app. That's it. So yeah, so these are the things that we are planning. Okay, so now the Docker is done. So you can see the new image. It has actually size of 3.44 GB. Okay, now you can do docker run it osrf rows humble. So you have to be caution, like if you want to play with the tag, so we have to add a colon. Okay, and then bash. Okay, so you can see after getting the terminal, rows2 let me see, rows2 help we have check, maybe rows2 package list. You can see by default it is this image having this much of packages, mainly the base packages. Okay, and okay, so now we can maybe run the demo nodes or demo. Yeah, the talker and listener. Okay, so I'm just copying this, running here. We have the talker running, and I need another terminal, right? So I'm just checking the container ID, and I'm using docker exec -it container ID bash. Okay, so now if you do roast topic list, yeah, so in this case, if you are taking the exec, you have to source this rows entry point, which is actually a shell script in order to do the sourcing of rows2, like /opt rows humble setup.bash, right? So which is actually doing inside the rows entry point. Okay, maybe I can, 1 second. Oh, okay, what happened was it's crashed. Okay, cat rows entry point, you can see here it is sourcing it. Okay, so if you source the rows entry point, then only you can access the rows2 commands. 1 second. So if you are doing docker run, it will be already running the rows entry point or sourcing it. So rows topic list, you can see the chatter, and now I am running the listener from here. Okay, so you can see here is 108, 109, it is hearing that. Okay, so this is a basics docker example that we can see. Okay, so in order to run the basic commands or something, you can use this method. Okay, and if you want to visualize something, if you want to open RVs, Gazebo, all this stuff, then you can either run docker with some commands. Maybe I can show you that. Docker rows. So we have to add like 1 second. This is the example for rows 1, but it will be working with rows 2 as well. So there is an option here. So if you run it, you have to mention these much of lines of code to make the GUI enabled. Okay, so I'm not interested to run with this, but in order to avoid or in order to run GUI safely, I am using the Rocker. Okay, so Rocker is a tool from Open Robotics. So their tagline is that a tool to run Docker container with overlays and convenient option for things like GUI. Okay, so it is actually working on the top of Docker. So what you have to do is you have to install Rocker using this command. Okay, it's very simple. You can simply install it, and then if you want to work with yeah, if you want to work with GUI and all, what you can do is you can run with Rocker. Okay, what I can show you that. So if you have NVIDIA, then you can mention the NVIDIA tag, but currently we don't have that, so I'm just removing it, and I'm just changing Crystal to Humble, and then I'm simply starting a terminal. Okay, so you can see here when you start the Rocker, maybe I can put the command here. So this is the command. So you can see it is running the Docker mainly, okay, with these options, and we got the terminal, right? So if we want to open RVis2, here is RVis2. Okay, this is not from our Ubuntu, that is different. This is from the Docker. Okay, if we want to run rqt, then what you can do is just create another terminal instance, bash, then source the entry point, and then rqt. You can see the GUI. Okay, and if you want to work with Gazebo, you can simply type Gazebo. Okay, so by default Gazebo is not installed. Okay, so what you can do is you can install it. One second. So you can install Gazebo and then you can able to run Gazebo. Okay, 1 second. So it's a similar to working with the Ubuntu machine in your computer. Only difference is that you have to learn some commands. That's it. Okay, so I'm just installing apt install rose humble Gazebo rose. Let's see. Okay, it needs like 366 MB or something, so let's wait for some time. Okay. Okay. Yeah, it's mostly finished. So we are going to install Gazebo now. Okay. Okay, it's almost done. Okay, so we have 1 second, guys. So we have installed Gazebo, and now it's a time for running it. Okay, so if you have a application with Gazebo simulation involved, you can simply run rose2 launch, your launch file. Okay, so rose2 launch Gazebo rose, I think it's gazebo.launch, I'm not sure. Okay, I didn't do the sourcing. And then rose2 launch Gazebo rose, then gazebo.launch.py. So if you do this, the Gazebo will pop up, and again it is not from our machine, it is from the Docker. Okay, so we have Gazebo. It's not slow, you can see here it is good. It will be working like we are working from the VMware. Okay, and you can put the model, anything you can do. Second, and we have the RVs running here. You can close it if you want, and do the docker ps docker exec -it, and then source rose entry point and rose2 topic list. You can see the topics from Gazebo. Okay, I hope you got my point. Like, you can able to run all the aspect of rose. Okay, and you may have multiple question now, like how to copy our files, like the source code into the Docker and run it. Okay, so actually what we are doing is we are just running the Docker image and then we are working on it, right? And if we want to create an application, okay, uh, what you have to do is, the better thing is to write a Docker file, a thing called Docker file. Okay, so I can show you what is a Docker file looks like. Okay. Okay. Yeah. So what is a Docker file? So Docker file is like a file like shell script. Okay. Uh, so you have to name the Docker file as Docker file itself. Okay. You can't change the thing or something. It is like cmake, makefile, or this all these things, you know, right? Cmake list.txt, like that. Docker file is Docker file. Okay. And inside that there are set of commands from Docker. Okay, so if you just uh, check like Docker file reference, the Docker is giving this much of instruction to us. Okay, and what is this instruction for? These instructions are for creating an image. Okay, a new image. So why we need to create image? So for example, if you want to deploy your application, okay, one option is to create a Docker file. Okay, and when you run this Docker file, it will be automatically do all these instruction, run this all instruction, and finally it will be creating an image. Okay, so it's a step-by-step instruction in order to create an image, and after that you can able to run it as well. Okay, you can able to run the image. Okay, so if you do that, you can able to copy the files from the host operating system, which is Ubuntu again. Okay, which is Ubuntu here. You can copy the files from Ubuntu to the Docker, and you can able to do the callcon build, all this stuff, and finally you will get the image and you can run it. Okay, so the Docker file will be looking like this. Maybe I can show you again. So mainly, like, the Docker file start from a base image. So in case of ROS application, we need to download a ROS humble Docker image. So from means it will be checking the image, base image is downloaded, otherwise it will be downloaded. Okay, and then it is doing the set of instruction to install the dependency, then copying the files from the host operating system, then doing the installation of ROS, all these things. Okay, and after that you can able to build this Docker file using this command. It's very simple. It's called docker build. That is the command that we are using for building Docker file. So you can compare this with makefile in Linux or cmake list from Linux. So using docker build, you can build the Docker file and it will be building everything and then finally creating a image with a name that we are mentioning here. Okay, so after creating this image, you can run it. Okay, so that is the Docker file, which is very useful in lot of situation. Like if you want to make your application portable, I will say to write a Docker file. Okay, one second. Okay, so do you have any doubt, guys, like regarding the Docker file? Any doubt? Okay.
Use the Docker. It's possible to use things like Raspberry Pi.
Yeah. We can use it. we can use it. So that's why it is very useful. Like you can run the Docker in Raspberry Pi, and then so it is very easy. Like you don't need to install the dependency on Raspberry Pi. You just need a Docker file. Okay, you just need a Docker file, and you can copy this file into Raspberry Pi and do the build, and it is ready. Okay, so that's how it is. Okay, it is very easy to build. Okay, and next is the compose. Okay, I mentioned, right, the compose is like a launch file. Okay, so maybe I can show you an example for compose that is actually in the main website itself. So this is a compose example. So one second. So here what is happening is that there is a version for compose, and here they are starting two containers. Okay, talker and listener. Okay, and the talker is using the image humble desktop, listener is also using humble desktop, and they are running this command. One is running this command. Okay, so these two things are working on different containers, but internally these containers are connected. So we can see how we can run the Docker compose, so you will get an understanding. So Docker compose up, that is the command to launch this Docker compose. So just do this, and then what it will does is that it will start the command that we are mentioning. So you can see it is one is publishing and one is like subscribing. Okay, so and if you do docker ps, you can see two containers. Okay, so these are internally connected. So even if Rose is like working in a network, it will be, I mean, communicating. Okay, yes, and if you want to stop it, either you can press Ctrl C or Docker compose down. Okay, so this is how we can do it. So you can see one container is stopped, and it is waiting for the other. Okay, so now if you do this, it is done. Okay, so this is the important points that we have to discuss in Docker. So using this technique, you can able to put any application on the Docker image, and then you can run it. Okay, yes. So yeah, I think that is the thing that I want to mention in this chapter. And one more point is the NVIDIA Docker, which is again very important. So I will be showing that. One second. So I mentioned that when we work with Rocker, we have seen one second. Yeah, we have seen a command like in Rocker space NVIDIA, right? So in order to make the graphics card or graphics acceleration work with Docker, NVIDIA actually giving a thing called NVIDIA Container Toolkit. Okay, Container Toolkit. So you have to install this Container Toolkit. So then what you will get is that your Docker will be enabled with the NVIDIA graphics card. Okay, so yeah, so you can see here, if you set up the NVIDIA container in Container Toolkit in your machine, okay, make sure you have the NVIDIA GPU with you. Then you can run like this: runtime equal to NVIDIA. Okay, so then if you do this, we can make sure the NVIDIA graphics card acceleration is getting in the Docker, which is very important because if you are doing some training or if you are working with some extensive simulation in Gazebo, graphics acceleration is actually very important. Okay, so NVIDIA Toolkit, if you are planning to have the graphics acceleration for your application, you have to install it. Okay, so that is what I mentioned with the NVIDIA Docker. It's basically Docker only, but it is like a toolkit we have to install, so it will be patched to the Docker, and you can use the Docker as it is, and Rocker also we can use with the NVIDIA acceleration. Okay, so the next topic is like a very small topic, but I just want to give some pointers into it. Okay, so so we actually gone through the Docker thing, like how to set up the Docker, then how to start working with Gazebo, Arvis, all this stuff. And the second topic is like how to test your ROS package, and then how to deploy it, how to release it, all these points. Okay, so I can say an example first. Okay, I can say an example. Imagine you created an application, okay, a ROS2 package basically. Okay, so you are one second. Okay. One second, guys. Let me just. I will get back to the example again. Let me just log into RoboAcademy. Okay. I can show you an example. Okay, then yeah. So you have created a package, your own package, and you have put it in the GitHub. Okay, so what happening is that the code may be working on your computer. So if you push the code into GitHub, by default the code will be there. Okay, then other people can just clone it and they will be running. But there is a thing called GitHub Action or Travis CI, or like I will say generally continuous integration or continuous deployment. It's called CI/CD. Okay, you maybe heard about DevOps, right? So what happening is that we can create or set up a pipeline in which if you push a code to GitHub, okay, imagine I have created a package called demo nodes cpp. I push the code to GitHub. Once you push the code to GitHub, automatically your package will be building. Okay, your package will build and it will create a report. Okay, so whenever you modify your code, the continuous integration or continuous deployment pipeline will ensure your package is working. Okay, so if you want to pull or if you want to raise a pull request, or if you want to merge some branches, these CI/CD pipeline is always there to make sure the code is working fine. Okay, so this repository is a dummy repository in order to demonstrate the CI/CD capability of GitHub Action. Okay, so GitHub Action is the CI/CD pipeline inbuilt in the GitHub. Okay, which is inbuilt, and you can simply keep a file inside your repository to start the CI/CD pipeline. Okay, and you can also see a badge here, right? So badge is showing it's passing means it is building properly. This package is building properly. Okay, so I can show you how to build or how to set up a CI/CD pipeline for a ROS 2 package. So you can see, just go to the action, and here you can take new workflow. Okay, and you can select a workflow, maybe um, like C, C++, or you can check whether if it is ROS 2 available, or you can check set up a workflow by yourself. Okay, and you can write your workflow here. Workflow means a set of instruction in which how to build your code, and after building what to do. Okay, or when to build the code, like when you make the changes or when you do pull request or something. So all this instruction you have to keep it in the workflow. Okay, like inside your repository there is a folder called .github. Inside that there is a folder called workflows. Inside that you can keep a YAML file, and that will be always executing, okay, when you do this. So as of now I have created a YAML file called ros2.yml, and this is the template how the continuous integration pipeline looks like. Okay, so like maybe I can just go through this thing. What happening is that this pipeline will be triggered when we push some code or modify some code on this master branch. Okay, and whenever we push some code, this branch will be, I mean this process will be initiating, or this job will be initiating. And what is the job? The job will be building and testing the package called demo.cpp. Okay, and which operating system it is building? It is building in Ubuntu latest. And which ROS distribution it is using? It is using Humble. Okay, and it is using the instruction from ROS tooling repository. So I can show you that. So there are predefined GitHub actions present in this repository called setup ROS. So you can simply use this action in order to build our package. Okay, so these are predefined, already written GitHub actions for a ROS 2 package. So you can simply use this, and then you can mention your package name. Okay, so you can mention the operating system, like if you want to test it in Windows, Mac or something, you can mention that. And also you can mention the ROS distribution, so it will be building in the appropriate distribution. Okay, so I can show you an example for this. So if I'm doing any change, so like I'm just going in the readme and I'm just changing it here, like I'm just adding a dot here and commit changes and pushing it. Okay, so I made a change, right? So the pipeline will be running. So you can see there is a check here. Just click it and you can see the test is running. Okay, so this is running. So there are two tests running. So you can see the GitHub action is basically running a Docker inside, and it is I mean after building all these packages and all, it is building the our package. Okay, so that is how it is working. Okay, so it will take some time. Maybe if you just check the summary of action, you can see whenever I pushed, it is actually building properly. You can see the job is completed. Okay, so that is the CI/CD pipeline basically for making sure your package is building properly. Okay, and I just created this dummy repository for copying the same thing into your project. Okay, so this is CI/CD. There is nothing fancy, but just keep a file on your workspace to build it whenever you change the repository. Okay, and one more thing is releasing your package. Okay, releasing your package. So you may have confusion, like after, if you want to contribute to the ROS package list, like we are installing the package like ROS Humble, then the package, right? So if you want to install it, if you want to release it, there are some setup instruction. I think we already discussed that in the ROS one as well. So you have to follow these instructions to make it. Like there is a tool called Bloom, and you have to do the Bloom release, and then you have to mention into the ROS distro file. There is a file here called distribution.yml. So you have to raise a pull request to this file in order to add your package to the main ROS package list. So you can see here there are tons of packages here. Okay, so all these packages, you can see the GitHub repository, right? GitHub link. So all these packages will be building and creating the binary, that is .deb file, when a ROS distribution is getting released. Okay, so you can so the thing is, you have to follow this instruction, which is already mentioned in the documentation, and you have to create a pull request. They're saying it will be doing automatically. Okay, so this is the instruction for creating a ROS package and publishing into the main ROS package list. I think I can show you that which is the main package list. So if you just take ROS Synaptic, and if you just search for ROS Humble, you can see the list of packages, right? So this is the official list of packages. So if you search for Turtleboat 3, you can see the Turtleboat 3 packages here, right? If you search for Turtleboat in the distribution.yml, you can see that packages. See that packages, what are the sub packages, all this stuff you can see. Okay, so that is what the continuous integration and release of the package. Okay, it is a small topic, and there is an additional tool, but that we are not using not using much. It is called Travis CI. It is doing the same job as the GitHub action. Okay, so Travis CI is another service in which you can log in through GitHub. Okay, and you can do the same continuous integration using this. Okay, so but I am preferring GitHub action because it's already integrated. Travis CI is also, we can check, but mainly like you can stick with the GitHub actions. Okay, yes, so these are the two topics that I want to discuss today. Okay, I think we have done that, and we can do a Q&A like after this. So let me know if you have any question regarding these two topics. We can discuss that now. Any doubts regarding the continuous integration?
No.
Yeah. So that is the thing, guys. Yeah. So next class, yeah, regarding the project, I think we can discuss at the end. Maybe next class will be, I will be preferring to take like ROS to Slam toolbox, and the ROS 2 controllers. I don't know. Mostly the Slam toolbox is like it will not take much time. We already did a demo of the Slam toolbox, but maybe, yeah, maybe let me see. I can take two of this topic. I will be announcing maybe tomorrow or day after that. Mostly tomorrow. Okay, tomorrow I will be discussing the ROS 2 Slam and ROS 2 control. Okay. Okay, then thanks for attending. See you tomorrow, guys. Bye, everyone.